Hello everyone, my name is Karan Mehta and I am from 3rd year Electronics Department of DJ Sanghi College of Engineering. Today's subject for the practical is Design with Linear Integrated Circuit. The name of the experiment is Application of IC555 in Monostable mode. Now let's see the working of Monostable mode. So, in Monostable mode, when a negative trigger is applied at pin number 2, the lower comparator changes its state from 0 to 1. Now as the state of this lower comparator is 1, this causes the output of this RS flip-flop as high. Now as the output of this RS flip-flop is high, the value of this Q bar is 0, because of which this transistor will act as an open circuit. Now as this transistor is an open circuit, this capacitor C1 will charge through this resistor R1 here. Now till the time this capacitor charges, the output of this IC is high. Now as soon as the voltage across this capacitor becomes 2 by 3 VCC, which is equals to the voltage at this point, the potential at non-inverting terminal of this upper comparator becomes higher than the potential at inverting terminal. This causes change of this upper comparator state from 0 to 1. Now as 1 is given to the R of RS flip-flop, this resets the output to 0. Now as the output is 0, the value of this Q bar is 1, and because of which this transistor will act as a closed circuit. Now as the transistor is closed circuit, this capacitor C1 discharges through it and again its value becomes 0. So the time period for which the output plus pulse remain high is given by 1.1 R1 C1. Now let's see the pulse width modulation technique. So in pulse width modulation technique, we are providing a continuous square wave at pin number 2, which will act as a continuous negative trigger input. And also we are providing a modulating signal at pin number 5 instead of connecting it to ground through a capacitor. So now as discussed, we are connecting a modulating signal at this pin number 5. Because of this, instead of 2 by 3 VCC, now the potential at this point will change at every instant. Now as the potential at this point is different every time, the time taken to charge this capacitor will also be different at every time. This will depend upon the amplitude of the given signal at pin number 5. Now as the charging time of this capacitor is different, the width of output pulse will also change according to that. This will cause in a pulse width modulation technique. Now as you can see in this waveform, when the amplitude of this modulating signal is high, the width of the output pulse is also very high, and as soon as the amplitude of modulating signal decreases, the width of this output pulse also decreases. So this is the schematic for PWM generation using IC555. Now let's see the same schematic in LTspice window. So now as you can see, I have already created the circuit. So here I am providing a modulating wave at pin number 5, which is a sine wave of amplitude 1.5 with a DC shift of 3 volts, whose frequency is 40 Hz. And at this point, that is pin number 2, I am providing a carrier wave, which is a square wave. So now let's run and see the output. This is the modulating wave. This is the carrier wave. So now let's plot the PWM output in another plane. So now as you can see, at the output a pulse width modulation wave is generated. Observe that when the amplitude of modulating wave is highest, the width of this pulse is also largest, and when the amplitude of this modulating wave is lowest, the width of this output is also lowest. So this is the PWM waveform. This PWM has many applications, such as to control the speed of motor in autopilot system, data loggers, and electronic speed controllers. So in this experiment, we saw the working of monostable multivibrator. Then we saw how to create a pulse width modulation wave using IC555 in monostable mode. and then we saw its output. So this was generation of PWM waveform using IC 555. Thank you.